Well, it's okay. So if it is okay, then next one, CDMA. CDMA use code. So different code to achieve orthogonality. And for code, actually you can think about a vector. How to have the orthogonality using a vector, I think it will be easier to think about the orthogonality. Likewise, since 2G, we can have CDMA. And orthogonality, of course, we can have the code. And the code maybe 1, 0, 1, 0, we should have positive 1 and minus 1. And we have the code. If we have the code how to have the orthogonality using vector, then I think it will be easier to check orthogonality. Up now, we have the same code. So we just know the same code and reach the destination. Well, up now, it's just an operation. If we have a minus 1 to serve as the information, and the positive 1, and then we'll have the waveform in terms of the codes. So minus 1, we need to alter the label to minus 1. Minus 1, positive 1. So we can have the way, so minus 1, positive 1, but 1, so positive 1, then minus. So this is minus 1 and positive 1. If we denote minus 1 to 0, so we have 0 first, and then we have 1. So bits will have 0 and 1. Well, this is a way to have the encoding and decoding if we employ CDMA. And for this, actually, all the received information can be summed, and so that we have the sum information bits, and then we can have some proper decision to have the decoded signal. Finally, yes, based on the current description, we can decode to have minus 1 and positive 1. Well, so that is a single transmitter and receiver. So we have that. And how about if we have two senders, and so that consider the interference. In fact, it says because of orthogonality, it doesn't matter. We can have first one and second one and put them together. We have the signal. But finally, talking about the received signal, how to extract the signal, no problem. We still can have minus 1 and positive 1. So it says for CDMA, it's really okay to have multiple sender to send signal simultaneously, and it won't have the heavy load to the receiver, so it doesn't matter. Well, if we have this, think about the code. We can have a code 1, 2, 3 to N, so that we have the different channel. Same. Uplink and reverse link, we can have the different codes. And previously, actually, we have the time and the frequency and multiply the code. So we have 3 possible dimensions to have time, frequency, and codes. Well, that's it. This is CDMA. After now, I think everything will be okay, right? However, allow you to have 2 minutes to think about TDMA, FDMA, and CDMA up to now. Well, 2 minutes to have the short discussion with your member. So why not you can sit closer, and so that you can have some discussion. And for Jason, Christopher. And if possible, you can look up your task in TDM. We didn't have the quick discussion about TDMA. Sorry, FDMA, TDMA, and CDMA. And later we will continue to talk about sparse virtual. Even in chapter 1, we've already discussed this for you. All right, 2 minutes to have a short discussion. Well, so if so, then we can continue to check sparse virtual. In fact, sparse virtual we already have, but in the past, I have the current discussion. Later you can check it, the current discussion. So again, we can directly have the discussion quickly for sure. And sparse virtual here, we have a code. So of course, we have a code here. And previously, we have a signal. Signal in terms of frequency and time. All right, so of course, S of t, in fact, it can be S of f and t. And so that we have this, but this time we emphasize it should be a function of t. So we just have a parameter t here. And power, we already have a power. So sparse virtual actually talk about the actually narrow band. So we have the narrow band, but we have the power there. And if we have the power, then we have a code. And code actually we can have the possible way to spray the signal. Well, spray, is it true to have the spray? Here we have a narrow band. And through this while we can have a spray because we have the code, and so that we have a high frequency. And so that we can spray the channel. So look at this. Spray the channel, right? Well, after now, then we emphasize spraying. How to have the factor of spraying, the code. The code actually we can have a high frequency. Can you accept this? High frequency for the code. Because we change frequently using the code. And so of course the code will result in the high frequency signal. So high frequency here, frequency narrow band, and right now high frequency, so we have a wider band. Well, because of this idea, that's why we have a narrow band and we have a wider band. And narrow band and wider band, actually we have the one thing unchanged. The energy. Actually, the area serving as the energy. So we have energy 1, energy 2. And because we have the same energy, so that's why area and area 1 and 2, they are the same. Because we have the same energy. Alright, so because of same energy, so that's why we have this characteristic. Even we have a narrow band and after spray, and then we have the wider band. However, narrow band and wider band will still have the same area because we need to have the same energy. Alright, so this is a concept for the sparse virtual.